Okay, today we're going to cover using PMVIEW to test PSCAD models. So I have here a PSCAD model I want to test. This is actually the an example case that comes with PSCAD. It's the simple SVC example. And before I do anything, I'm just going to save it into my own personal folder so I'm not messing up an example folder. All right. First thing we're going to do, we're just going to make sure it runs okay. Always good to make sure the case you get runs before we add the PMVIEW block, do any testing. And yeah, it just ran. You can see I get some plots here. The SVC does produce reactive power, whatnot. Okay. The SVC is connected to a very simple system model, which is just a generator. They apply a fault. First thing we should note is the system voltage, which is 130 kV. We're going to remember that for later. And let's now add the PMVIEW to the case. So I'm going to open up the case here in the Explorer window. And here I've downloaded PMVIEW package and opened it up and unzipped it. And all I need are the library files and then the text profiles. So the library is the PSLX file plus the profiles that contain the different tests. So here we go. I'm going to copy those over. And now we're going to load that library into PSCAD. There it is. So here is PMVIEW, the library is loaded, and here's the test block. And we can run it through multi-run if we wanted to cycle through all the different tests. The tests are listed here. To put it in our case, we're going to copy it. Because it's in the library, we don't need to use copy transfer. We can just copy it, and I'm going to go in my case, and I will paste it. Now, I want to connect it at the POI, so I'm going to remove the AC system. I'm going to mirror it, push the M key on the keyboard, and then get the wire and wire it to the POI. So the PMVIEW block is now serving as the infinite slack bus, and it is controlling the POI bus voltage and angle for the test. I need to specify the test profile, and I can do that with an integer constant. So first thing I need to do, remember the POI was 130 kV, so I need to go in here and set the voltage just like it says here for each one of these sub blocks. To be 130 kV. Inside the PMVIEW block, there's these 3 sub-blocks. Most of the tests are run by the voltage and angle block that controls the voltage and angle profiles. This block is used for the IEEE 2800 HVRT transient portion. So it injects a special transient, a very fast transient. And this block is used for the short circuit ratio test. It needs some additional logic for that test. But if you wanted to see any of the test profiles, you could go in this voltage and angle block. And it's basically this large switch selector that goes through, depending what test you're running, it selects the different lookup table profiles. And there's a shortcut to them here. So for example, if we run profile 2, we will be using the LVRT profile, which is listed right there. And that is right here, this file. Same file, that's just a shortcut so you can see it in PSCAD. Same file opened right there. You could actually edit it if you wanted to change what the profile is being run. And you can see it starts out at 1 per unit, then it goes down to 0. Time is on the left, voltage per unit is on the right, then comes back up to 0.9, 0.95, and then it continues that way for 18 seconds, and then all of our profiles have this extreme point at the very end, if you run it all the way to the very end, which tests if the device protection is actually there and functioning. So here it makes a long period of 0.1 per unit voltage. And for most devices, that should trip them, and that verifies they have realistic protection. If the device stays online for this last test, where we have 6 seconds of 0.1 per unit voltage, then that probably means the device is missing protection in the PSCAD model. That should be tripping them at the end. Okay. So profile 2 is LVRT. I think I will want to test that one. So let's, instead of profile 1, let's get profile 2. Okay, and then the last thing I need to set before I run this is the start time. So I'm going to right click on my PMVIEW block and set edit parameters, and I'll set the time delay. You need to make this long enough so that the PSCAD model you're testing has enough time to initialize. Most models require a few seconds to initialize. Some IBRs require as much as 5 seconds, so you want to put in a delay of 5 seconds before you start your test. This model actually initializes really fast. You can see the voltage and the reactive power pretty much initialized even within half a second. So I think it's safe to do a 1 second delay. But normally 5 seconds, 3 to 5 seconds is probably what you'll want to use for most IBR models. And then last, how long do we want to run this? So most profiles go out to 30 seconds. I think I just showed you, like this LVRT profile goes out to 30 seconds. But we have a 1 second initialization. So we should run it to 1 plus 30 is 31 seconds. So enter that in. I'm going to click run, and we'll hopefully see it run. And there it's running. You can see in these plots they're included with the SVC model. You can actually see the LVRT curve. I'm going to go in the PMVIEW block because I like the plots that are included in that block a bit better. I'm going to click on them and hit the R key to resize the windows. And if you go voltage resize, hit the R key again. There you can see the beautiful LVRT curve that is well known. And there it goes down, it comes back up. And you can see at the very end we have this long period of 0.1 that should trip IBR models to test they have realistic protection. This top plot shows the real and reactive power at the point of interconnection. And you can see, let's take a look at that. So this looks reasonable. The real power is approximately 0, the blue trace, which would make sense for an SVC, which we're testing. And then the reactive power is going up and down. And it looks like it's set to absorb reactive power, but then as soon as we hit a low voltage, the SVC starts producing reactive power until the voltage comes back up, and the SVC switches to absorbing until it comes back down again. If I resize it again, see the full window, you see this SVC actually does not trip despite this really long, low voltage. So it's probably missing some protection model, which is not surprising. It's a simple example. And there we have run the LVRT. So if we wanted to run a different profile like HVRT, we would just change the test. HVRT is number 3. We could just change the number here to 3, and we would get an HVRT plot and hit run. Go inside to watch the plots. Resize this. There you can see the high voltage ride-through curve. And sure enough, the SVC is absorbing reactive power during the high voltage ride-through event. There's some other plots down here. They're included. There's current at the POI, and then there's instantaneous voltage as well. I just resized it. So this is instantaneous, so it actually has the waveforms. If you zoom way in, you can see the 3-phase sinusoidal waveforms. So that is running PMVIEW. On the next video, we will use the multi-run to automatically step through all the tests and be able to pull the plots for that. Hope you enjoyed this video and using PMVIEW.